We'll now make an example of a freeform profile housing script box, just like the 4 other boxes we have put together in this series of videos, with housing profiles, side sections, a U-box and a 4-fold box. Oh, I think it was the other way around. Yeah, like that. But now also with the freeform profile housing script, because they can all make rectangular boxes. So although this is not the most typical example, it still features a little detail which is nice and interesting. So now watch the fast forward assembly of this box. And there you go, a basic box, almost in the same dimension as the other ones. In this case, I made it slightly different in the front dimensions, though. But the main difference to a U-box in this case was that I had ends of this box, and I also had a special bottom where I bent here, 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 and here. So what is nice about that is if you look at the box from the side, you see the similar edge on both ends, rather than on a U-box where this has a different ending than the top edge, which is bent 90 degrees. It's a matter of taste. I guess the price is more or less the same. No, actually it's higher for this one, because since we have a bottom like this, which with separate ends, that adds to the cost, or at least it's a slightly different price. Anyway, it's a feature that you'll only get with the freeform profile housing. And of course there should have been an end here, but I guess I forgot to order 2 ends, similar ends, and I just have one here. I placed some rubber pads here because the bottom panel was connected to the main body by screws, which has a small cylinder head. All right, so that was 5 different types of basic boxes made with housing scripts from SKAARHOJ. So let's take a look at how this box was actually put together. Inside Front Panel Designer, you open the scripts dialog, select freeform profile housings, and if you just run it, I think you will get the Ugly Joe panel, unless it crashes on you. And as I've said before, it's a current bug at the time of as I'm speaking in the application, where if you have closed down some panels generated by a script, it may crash. So make sure you save your stuff. Otherwise it's not unstable. But I'll now run the script again. And yeah, you can see by default you get this. All these sides and so on involved in making Ugly Joe. And you will notice this one. You will recognize it from my introduction to using the freeform profile housing script. What we do instead is to open up the script, because we need to do some editing in the code. Yeah, and so that was the demo case here. What I'm looking for is if we can make a small standard box. And I think we're looking at it right here. Small box with only bottom. So I uncomment this, press start, and there you see we have one end, the side that was bent 4 times, the bottom, and the front. If you look at the file names, first of all, the front, of course, let's go to outline mode so we can see the outline of the box. The front, here you can see from the side exactly how it is bent together, and it should correspond to what you have just seen me do when I assembled the box. So if we are looking at the bottom side and top side, yeah, they look like this. They also have nice outlines. This is all enabled because we have this concept of guideline engravings, which are orange engravings that will, if you don't remove them, they will actually be engraved on your panels, but they help you to see how things fit together and not to make collisions between cutouts and your underlying features. And then the end of the panel. But how does this script actually work? So if we go back to the script, you can see that the depth of the box, and the depth of the box will be in this direction. So here you see it from the end. So this would be the front and the back, the width and the height, and this is the depth of the box. And that's set to be 100. We have a default side thickness is 2 millimeters. So this is 2 millimeters aluminum and not 2.5 like I used to use. The end thickness of this panel at the end is 3 millimeters, and the other end if I had it. And then there's something called ends mode. That's a little bit advanced. I'll get back to that. And some other features we will not discuss at the moment. I have defined the side colors to be red. Let's say I type in blue here, Elox blue, then I will get partly blue box. The important thing is the coordinates. So let's take a closer look at those. Now there's another video in this series called, what is it called? It's about this script called panel shape from coordinates. And it's the same concept. Basically that you have a set of coordinates that define points on your panel. So if we look at this one, the idea, the basic foundational idea of creating a box here is that you define coordinates for everywhere the panels are bent. So we start out by the coordinate 0.0. As you can see here, 0.0. And then we go to 0.56, as you see here. Then you go to 100.56, and then finally 100.0 here. And they are the basic coordinates of the box. And now comes the advanced part, because you can see that we do not only bend the panel here, somehow we also must be able to determine where are the housing brackets, and also where are the border between the bottom panel and the top panel here. So if you take a look at what happens on the third place of the coordinate sets, you see for the first coordinate set, which was 0.0, you see that on the third place, it's defined 10, and then comma, the height of the box, which was 56, minus 10, and that is the position of the housing brackets. So third place is the housing brackets. The first housing bracket is placed 10 millimeters from 0.0. The second housing bracket is placed 10 millimeters from the height of the box, which was 56. And the same thing will be true when you look at the third coordinate set here, because there you have exactly the same, a specification that over in the other side, those housing brackets are also placed 10 millimeters from the edges. So then how do I define that I want to break the panel here and here? Because you must have at least one break. You can't have no breaks, because the panel has to be put together somewhere. And the script is not clever enough to do this for you. Therefore, if you go to the last one, this is where it's defined. So basically the principle is that if you go from here 0.0 and you want to have housing brackets on the side that comes from that coordinate, you specify them on the third position. On the fourth position in the coordinate set, you specify if there are places where you want to break the panel. And that's exactly what we see here. The third was the coordinate set for housing brackets, but there are no housing brackets on the lower side. So the fourth is where we define where we want to break the panel. And now we have an interesting convention. The minus, ignore the sign in front of the coordinate. Really, this is just distances. So what this tells us is that 10 millimeters in on this edge number 4, we will have a break, and then 100 millimeters minus 10 from the other edge, we will have a break. And that's what it says right here. And the sign in front has a different role to play. Now, okay, to see if this is true, what I'm telling you, let's try to mess up the coordinates a little bit. First of all, we could try to change this to 20 and 30. Let's just put in 20. Let's add a housing bracket on the bottom side. Let's make it 30 millimeters from the edge over here. And then let's just run this and see what happens. Okay. So here in the background, let's just refer to the outline mode. So what we see is I now placed a housing brackets 20 from the corner. Over here on the other side, we have untouched housing brackets, and then we place the housing bracket 30 millimeters from this corner. Okay, so that seems to work. What happens if we change this minus 10 to 10 instead? And now you really need to watch, because this is now about the sign of the specification of where the panel is breaking. So I run it and I go to outline mode. Okay, so what you need to notice now, and you need really to look closely here, is what is the difference? And it may actually be difficult to see by the naked eye, but the difference is that in the lower example, where I used the parameter minus 10, you see that the bottom panel is on the outside of the large panel. Up here, it is on the inside. So this is necessary. If you want the bottom to be screwed onto the other panel, of course you need it to overlap from the outside, instead of this scenario up here where you would have to take the box apart or slide the panel in or something. So that was the difference of that coordinate. All right, so that was an introduction to how to make this kind of box. If you want just a rectangular box, you really don't need to use the free-form profile housing script. But if you want some crazy Joe form, like I've demonstrated in the introduction video, you do need it. And the next examples are going to show the power of this script even more.